Hi everybody, we're going to go through two topics today that are essential to know and fairly straightforward. We're going to go through evaluating trig functions for non-acute angles, so something that's not between 0 and 90 degrees. How do we evaluate the trig functions for say, a 120 degree angle? And then we're also going to look at something called reference angles. Reference angles are they have a lot of use, so we'll go through those two topics. Let's just start here. From yesterday, some basics. Angles that we'll work with in this course will be drawn in standard position. So that means the angle will be at the origin. That gives us an x and a y and an r value that we'll use to make our trig ratios. All right, now here's an example of a quadrant one angle, so maybe this is 50 degrees. Okay, so we have our sine, cosine, and tangent for this particular angle. All right. Now, today, the way that we extend this is that we say, well, what if the angle is, say, quadrant 2? I don't know if you can hear that horn honking outside, but it's, somebody should check that. All right, let's take a look at this picture. Here's a quadrant 2 angle. Maybe it's 120 degrees, 150 degrees, whatever it is. We can't really draw a right triangle for angle theta because it's greater than 90 degrees. With that being said, we still have definitions for trig that involve x and y and r when we're dealing with graph paper or an xy axis like we have. So what we look at is called a reference angle for any angle that we're dealing with. So here's the angle theta, 150 degrees. If we take a point that's on the terminal edge of theta, like this xy point, and we drop it down and form a 90-degree angle, we have a right triangle that will allow us to find all of our sines and cosines and tangents for the original angle. And we call this the reference angle. So the acute angle formed with the terminal edge of an angle that you're working with and the x-axis is called the reference angle. Now, in an angle that is already acute, we don't really need the concept because this angle is already of a size that you can actually draw a triangle and find your trig ratios. But this concept of a reference angle, we call this theta prime. Theta prime is the reference angle of theta. This concept allows us to find trig ratios for any angle that we could put on an xy axis. And that might be something larger than 90 degrees. It might be negative. It might be larger than 360 degrees. This concept can apply. All right, so let's just take a look. And so keeping in mind these two pictures, here's an xy axis, and we're imagining what if theta was something between 0 and 90 degrees, or 0 and pi over 2 if you're in radians. What if we had an angle of that size? How would it affect the positive or negative sign of our ratios that we're forming? Meaning this, and I'll just draw a small angle here just so I don't clutter it too much. Here's theta. I know that if I draw a triangle in quadrant 1, there are a lot of things that are positive. For instance, from the origin to the right, that x is a positive value. I can put a little plus next to it. The y is also positive. The r will always be positive because it doesn't go in any direction where you could have a negative, like left, right, up, down. So by default, the r value will always be positive. If I put these ideas together with my sine, cosine, and tangent ratios, I see that sine must be a positive divided by a positive. And that just tells me that if I did the sine of 50 degrees, I expect to get a positive answer. Okay. Same thing with cosine and tangent. All of these ratios will result in positive values. So cosine of 50 degrees is positive. Now, I don't know off the top of my head what that's going to be as a decimal, but I know it will be a positive amount. Okay. In quadrant 2, if I draw a triangle with an angle that is larger than 90 degrees, so there's my second angle, and then I have a point that it goes through. If I draw my reference angle, theta prime, and I think about the y value and the x value and the r value for the triangle that I have in the picture, and even thinking without the triangles, you don't really need them if you know the x and the y and the r ratios, but they're a good visual. I know the x is negative because it goes left from the origin. I know that the y value would be positive because it goes up, and the r value will always be positive. So if I consider all of my ratios, y over r, well, that's going to be a positive divided by a positive. So I'll guarantee that the sine of 120 degrees, which is a quadrant 2 angle, I guarantee that's positive, right? Cosine. Okay, so that's going to be x divided by r, a negative divided by a positive. Well, that's going to be negative. So in this particular quadrant, I guarantee that the cosine of a 120 degree angle or 150 degrees will produce a negative result. Whatever that result is, it'll be a negative value. Tangent is y divided by x. Okay, so y is positive for a quadrant 2 angle, x is negative. The result is negative. So in my first quadrant, all trig ratios were positive. In quadrant 2, only the sine ratio was positive. So if I did the sine of 150 degrees, that's positive. The other ratios would produce negative results. All right? And so before we can move on, we have to just establish what's positive and negative out of our big three ratios, what's positive and negative in each quadrant, and that's going to allow us to find sine and cosine values in different quadrants and know whether they're greater than 0 or less than 0. So at this point, if you could please try, determine for quadrant 3 and determine for quadrant 4 which, if any, of the sine, cosine, tangent ratios will be positive or negative. And to help you get started on that, I mean, we could draw a third quadrant angle with some point, xy point, and my only question would be, all right, once you've dropped a 90 to the x-axis, once you draw a line to the x-axis, what's positive and negative in your diagram? Is the x positive, is the y positive, are they negative? And then your fourth quadrant, if you'd like to get a picture for that, you can see how cluttered that was. Here's a fourth quadrant angle. Goes all the way around, maybe something like 200 or 300 degrees, something like that. So here's how you would draw your triangle in quadrant 4. Reference angle always at the origin, okay, and then determine what's positive and negative. Okay, so give that a shot, and then we're going to talk about that in a couple minutes.